Good evening, everyone. Good evening. Everybody's hearing me? Good evening.
Good evening, sir.
All right.
Good evening, sir.
Good evening. All right, so welcome back to another session, the second for the week. All right. We're going to be picking up from where we left off in our last class, I believe we were on the topic of fractions. So tonight we're going to tie up some loose ends when it comes to fractions. The objective for tonight is going to be to obviously we have to do a quick little recap for the persons who weren't here last class. And we are going to be moving on to multiplication and division of fractions, as well as we're going to be doing some structured exam questions, where we're going to be doing fraction problems using PEMDAS. So that's the overall objective for tonight. So at the end of tonight's class, hopefully everybody should be able to work or evaluate any fraction problems that is given to them, provided that the requirement is to add, subtract, multiply, or divide. Okay, so let's begin. So we're going to start off with our usual recap. All right, good, wonderful. That's a whole lot of markings. Hold on, let me just clear the screen, guys. Big swipe.
Sir, I'm not seeing the screen.
My screen is being shared, so I'm not sure. You want to exit the room and come back in?
Let me do that.
Yeah, because my screen is being shared. All right. All right, guys. So recap. So let's get that done. So in our last class, we looked at addition and subtraction of fractions. So let us go ahead and choose a question. So we have 2 and say a quarter plus 3 and 2/3. All right. And as discussed in the last class, step we give. Pardon me?
I'm seeing it now.
Okay, wonderful. All right. So as discussed in the last class, right, I gave you 5 steps to approach the fraction problem. And if you are looking in your notes, as written down from last class, step 1 would have been to convert any and every mixed fraction to an improper. Did we get to this stage, by the way? We did, right? I believe we did.
Yes, sir.
Okay. I just want to make certain that I'm not jumping the gun. All right. So we have 4 times 2 is 8. 8 plus 1 gives us 9/4. And then we have 3 times 3 is 9. And 9 plus 2 is 11/3. And the easiest way to find the LCM is to multiply the numbers at the bottom. So that would have been 4 times 3 is 12. Now we are going to find out how many groups of 4 are you guys hearing me?
Yes, sir.
Right, I think I lost it for a second here. My bad. Okay. All right, so 4 multiplied by 3 is 12. So 4 into 12 goes 3 times. We're going to put that 3 right at the top here. And then we have 3 goes into 12 4 times. We're going to put that 4 right at the top here. And we're going to multiply. Now, 9 multiplied by 3 is 27. And 4 multiplied by 11 is 44. So by adding these two numbers, 27 plus 44, that's going to give us 71. Can we confirm?
Yes, sir.
Over 12. Now, of course, we need to leave our answer in its lowest form. And the lowest form of an improper fraction is a mixed number or mixed fraction. So we need to find out how many groups of 12 can we get from 71, or how many times can 12 go into 71? And I believe that you'll find that this goes approximately 6 times. So, yes, 6 times. And so the remainder, no man, 5 times. 6 is too much. 6 times 12 is what? 72, no, so? That gone past 71. So it is not 6 times, it's actually 5 times. And that will leave us a remainder of 11, all divided by 12. Okay? And that's how you would add 2 mixed fractions. The process is very similar when you're subtracting. Let's say you end up with something like 5 3/5 minus 2 1/4. Since I used 2 1/4 already, let me just change it. 2 1/3. So the process is very similar. Step 1, convert any and every mixed fraction to an improper. So 5 multiplied by 5 is 25. 25 plus 3 is 28, all divided by 5. Minus 3 times 2 is 6. 6 plus 1 is 7 over 3. Now, by finding the LCM, which is to multiply the two denoms, that's going to give us 15. And so we can get 3 groups of 5 from 15, or in other words, 5 goes into 15 3 times. And 3 goes into 15 5 times. Now we proceed. 28 multiplied by 3, that's going to give us 84. And 5 multiplied by 35, that's going to 5 multiplied by 7, pardon me, give us 35. And so by mere subtracting the both numbers on the line, 84 minus 35, that's going to give us 49. And that will be all over 15. Once again, we end up with an improper fraction as our penultimate answer. So we end up with 49 over 15. So we end up with 49 over 15 being our penultimate answer, but we need our answer to be written in its lowest form. So therefore then, it seems as if we can get 3 groups of 15 from 49. And 3 times 15 is 45, so there's a remainder of 4. And that would be all over 15. All right? And that would have been a basic recap of, well, majority of what we did in our last class. This would have given us a recap. So for the persons who are new, or for the persons who missed out last class, hopefully that 10 minutes is of aid to you. Any questions before we move forward? Anybody have any query, any questions before we move forward?
No, sir.
All right. Doesn't seem as if I have any questions. Wonderful. Now, just before I get to multiplication, I just need to do one more problem, right? And this is a case where sometimes you end up getting 3 fractions to simplify. Please take a screenshot from now if you need to, or if you're writing already, I'm about to erase the screen. So take a screenshot if you need to. Now you may end up all right, so you may end up, let me just change this back to black. Okay, good. So you may end up with more than two fractions that you have to add or subtract together. So in this case here, let's look at this question. We have 3 and 2 over 5 minus 2 and 1 over 4 plus 1 and 3/4. No, let's not use fourths. Let's use 3/7. Now, in this case, it's okay if you want to say work this part first, get the answer, and then work it with the addition. You can do that if that's what makes you comfortable. Or you can simply, because the rules for subtraction is the exact same rules for addition, we don't need to segregate the problem. We can just do everything one time. All right, so you have to choose what makes you comfortable. In this case, I feel like just to make light work of this, we can just go ahead and find the LCM for all three at the same time. Now, the only way we couldn't do what we're about to do is if there was a multiplication or a division involved, because the rules for division and multiplication differs from the rules for subtraction and addition. So since the rules for subtraction and addition are the same rules, we can proceed to find the LCM for all three fractions simultaneously. But of course, you know that we have to convert all the mixed fractions to improper. So we have 5 multiplied by 3. That's going to give us 15. And so 15 plus 2 is going to give us 17. So 5 multiplied by 3 right here. And then we add back the 2 right here. So 5 times 3 is 15. 15 plus 2 is 17 over 5. Take away. 4 times 2 is 8. And 8 plus 1 is 9 over 4. And then we're going to add now. 7 times 1 is 7. Plus 3 is 10 over 7. Now, again, if you feel like it's better for you to find the LCM of this and then work it out and then bring down the 10 over 7, no problem. I feel like that's a lot more work than I need to do. I can just go right ahead and find the LCM of both, of all three. So the easiest way to find the LCM here is to simply multiply all three numbers at the bottom. And so 5 times 4 is 20. And 20 multiplied by 7 is 140. Now, using our calculator, 140 divided by the bottom number, which is 5, that's going to give us 28. We're going to put 28 at the top here. You can verify that for me while you're calculating. And 4 will go into 140 about 35 times. So I'm going to put my 35 right up here. And then 7 goes into 140 20 times.
Sorry about that. I missed the part when you said 17 times 28.
Oh no, I haven't done that as yet. I only said 5 into 140 goes 28 times.
Okay then.
All right, so 140 on the calculator divided by 5 will give you 28. And so 28, so now I'm about to multiply now. Now, let me grab my calculator. So I have my calculator at hand, just like you are supposed to have yours as well. So that's 17 multiplied by 28. That's going to give us 476. And 9 multiplied by 35, that's going to give us 315. And 10 multiplied by 20, that's going to give us 200. So we now process the calculation on the line. That's 476 minus 315 plus 200. That's going to give us a total of 361, or divided by 40. 140, pardon me, 140. Now at this stage, leaving it here, you're still going to get majority of the marks that's affixed to the question. But I do strongly encourage that always write your answer in its lowest form. Okay? So in this case, if I were to take my calculator, and I'd say, if I type on my calculator 361 divided by 140, it's going to tell me that the answer is 2 point and those bunch of decimal places, 2.578571429. So the only number I am interested in is the one that comes before the point, which is the 2. Now I need to calculate my remainder, and my remainder is not the bunch of decimal places that you see there, ladies and gentlemen. To get the remainder, you're going to take the 2 that you've just written down and multiply it by the denom, which is 140, and that's going to give you 280. And so you subtract the result of 280 from 361, and it should produce a remainder of 81. And then you put that right back over 140. And that becomes your final result. Yes? Are there any questions from anybody before we move right along?
This format is kind of confusing for me. I would rather do it step by step.
Which part of it is confusing?
Doing all 3 at the same time. I would rather do the first part.
No problem. Do the first 2, get an answer, and then bring down the 10/7 and then find the LCM again. No problem. No problem. Do it whichever way makes it easier for you. All right? Is that fine?
Yes, that's fine.
All right, good. All right, ladies and gentlemen, we're going to then move on to multiplication and division of fractions. All right, so head up that for me, guys. The title, the heading is multiplication and division of fractions, but we're going to attack the multiplication part first. Then we're going to do the division, and then we're going to tie everybody into one question. All right, so head up that for me. Multiplication and division of fractions. And remember, guys, I'm dictating because I don't have the luxury of writing on the screen as legibly as I would like to. So we're going to be dictating. Okay, ready? Let's go. When multiplying or dividing, well, let's not do the division. Multiplication first. When multiplying 2 or more fractions, when multiplying 2 or more fractions, we need to find a common factor. We need to find a common factor that can be used to reduce numerators and denominators. You need to find a common factor to reduce numerators and denominators. Full stop. So starting off with a very simple example so you guys can get the feel of what we're doing. Let's say we end up with a problem that then requires us to say here 8 over 9 multiplied by 27 over 4. And you're asked to simplify the fraction given there. You'll realize here that 9 can actually divide into itself once. And if you try to divide 27 by 9, you'll find that it goes 3 times. And you look again, you see 4 will reduce itself 1 time, or 4 into itself 1 time, and 4 cancels or divides into 8 twice. And at this stage, you pretty much have nothing else to reduce, because 2 and 3 are prime numbers and 1 is a universal number. So 1 into any number is the same number, and you cannot cancel numerators with numerators. So at this stage here, you're only left with one thing to do, and that is to multiply the numerators and multiply the denominators. So in this case, 2 times 3 is 6, and 1 multiplied by 1 is 1. And so 6 divided by 1 is the same exact result as saying that the answer is 6. All right? Very simple so far. Not too challenging yet. Okay? Not that I think it will, but no challenge as yet. Let's look at another question. That one was too easy. Let's try to make it a little bit harder. Let's say we end up with something like 4. Oops, pardon me. Hold on. Let's say we end up with something like 4 over 11 multiplied by 33 over 12. And I don't want to use 33 over 12 because something can go into 12 and 33. So I want to use something different. Let's do, oh, that's a big rub. Hold on, guys. Give me a sec. So that's 4 over 11 multiplied by 33 over, say, let's do 15. No, I don't want to use 15. Let's do 14. I think somebody just, give me a second, guys. Let me see if there's somebody that's in the waiting room. Is there anyone in the waiting room? Oh, there's no one in the waiting room. Okay, that's fine. All right, so back to the question. So we have 4 over 11 multiplied by 33 over 14. Now, right away, if we look carefully, you will realize that 33 can be divided by 11. And that will go approximately 3 times. And 11 will divide into itself 1 time. But look across to the next diagonal, you'll realize that 4 cannot go into 14. However, there is a number that can go into 4 and into 14. So unlike example number 1, where the actual numbers that were there were used to cancel themselves, in this example here, the number can't cancel itself. There has to be a number that can go into 4 and 14. And in this case, we end up with the canceling factor being 2. So 2 into 4 goes 2 times, and 2 into 14 goes 7 times. So now, since as everything has been reduced to its pretty much lowest form, our final answer then is going to be to multiply
6
across.
over 7.
Right, 6 over 7. That's 2 times 3, which is 6. And 1 times 7 is 7. All right? And that is our result there. Okay? Now, you could have, it can be a situation where you end up with 3 fractions to multiply. All right, so you could end up with something, let's say, like this. Let's say end up with 3/8. Whoops, pardon me, guys. Let's take out this big rub. Okay. All right, so we end up with now 3/8 multiplied by 14/9 multiplied by 15 let's say 15/22. All right, so 3/8 multiplied by 14/9 multiplied by 15/22. So the idea is that we need to cancel numerators with denominators, and the cancellation can take place anywhere across the board. So I'm looking at this now and I'm saying to myself, all right, I can actually go ahead and realize that 3 can go into itself once, and 3 can go into 9 3 times. Okay? Since I'm already at this 3, I'm going to check to see if this 3 can go into anything else. So I'm going to say 3 into itself again 1 time, and 3 into 15 5 times. And I have a choice here. I can either choose a number that can cancel the 8 and the 14, or I can choose to cancel the 14 and the 22. As my grandma always says, 6 or 1 half dozen are the same thing. So you choose. If you decide that you're going to say 2 into 8, 4, and 2 into 14, 7, you're going to still end up with the same result if you had said 2 into 14, 7, and 2 into 22, 11. So options, your choice. I'm just going to stick with this since this is the last step that I took. All right? So in this case now, I've ended up with nothing else to reduce. 5 cannot go into 8, 7 cannot go into 11, and 8 cannot go into 1, and 11 cannot go into 5. So I'm left with now 1 multiplied by 7, which is 7, multiplied by 5, which is 35. And then at the bottom now, we end up with 8 multiplied by 1, which is 8. And that 8 again multiplied by 11 is 88. So end up with 35/88. And that's a proper fraction. So then that's our final answer. All right? Do you guys follow? Any questions? It seems as everybody's knocking it out of the park.
Sir, could you explain how you get the 35 again and the 88?
35 is the remaining numbers that are left at the top of the cancellation. So the 1 that is over the 3, the 7 that is over the 14, and the 5 that is over the 15.
Yeah, you times them.
Mm-hmm.
Okay. And then you times
the 8 and the 1 that is underneath the 3, and the 11 that is underneath the 22.
8. But I thought to cancel out that 8. We didn't cancel that 8, no?
No, we didn't. No, we were saying that you could have canceled the 8 with the 14.
But that's what I did. I canceled the 8 instead of the 22.
All right, that's fine. Let's see if we do it that way. If it's going to change our answer. Remember, our answer is still 35.
Okay.
So let's do here. All right, so we're going to say, let's put back our 22 here.
Mm-hmm.
So you cancel the 8 and the 14?
Pardon, sir?
What did you say? You cancel the 8 and the 14?
The 8, yeah. So by
so that's 7.
Yeah.
And that is going to be 4. So it's still 35 at the top, and 4 times 22 is 88. Is it clear?
Yes, sir.
Okay, good. All right. I'm not ready to give you any to try as yet. Right? Not yet, because I feel like these are still at I still feel like these questions are at your level where you can manage. So we're gonna squeeze in some mixed fractions. Now I'm just going to be making up the fractions just out of my head. So it's not like I'm looking from a textbook because I want the question to be random. I want to end up with a situation where nothing can be cancelled out. I want to also end up with a situation where only one of the diagonals can be cancelled out. And I'm hopeful that I can make up an example where everything gets cancelled out. So let us just make it random. And why I like doing random questions, because I want you guys to also be able to say, you know what, Mr. Pierre didn't send me any work this week, but we can make up my own questions then. Because that's what I'm doing. I'm making up my questions. I'm not using a textbook. Okay? So you guys can make up your own questions as practice. You can just come up with some random numbers. Just keep them, don't make them too big and out of the norm. Okay? So like this now, I just make up some numbers in my head. I'm just saying 3 3/4. Oops, pardon me. So 3 3/4 multiplied by 2 and 2/7. 2 and 2/7, right? Now, let's go ahead and convert, pardon me, the mixed fractions to improper. Let's see what comes out. 4 multiplied by 3 is 12. And 12 plus 3 is 15/4. I'm going to multiply that then by 7 times 2 is 14. And 14 plus 2 is 16/7. Good. We end up with a really nice question here where only one of the diagonals can be cancelled. 7 cannot go into 15, so we're not looking at that diagonal. But if you look at the diagonal of 4 and 16, you'll then realize that 4 can cancel itself once, or 4 into itself once, and 4 into 16, 4. So then our final result for this particular mixed fraction question here is 15 times 4 is 60. And 1 times 7 is 7. But we end up with an improper fraction which we have drilled so many times over that leaving it like that may cost you a half a mark. So you want to make sure so you don't give up anything. Do not drop no catch. So 60 divided by 7. 7 will go into 60. I know that 7/8 is 56. So I think it will go into this about 8 times. And since 7/8 is 56 and I need to get to 60, my remainder is going to be 4. And that's going to be all over 7. And that's my final result. Is it clear?
Yes, sir.
Let's do another one. I feel like I wanted it too easy. Oh, try to make it harder. Try make it harder. Let's do 5 3/5 multiplied again by 3 3/4. Why me keep on I use 3 3/4? I feel like I just love that number too much. So times 3 3/8. Proceed. 5 multiplied by 5 is 25. 25 plus 3 is 28/5. And 8 threes is 24. And 24 plus 3 is 27/8. All right, nice. We'll end up with the other diagonal be able to cancel. So this time 5 cannot go into 27. And funny enough, 8 cannot go into 28, but there is a number that you can use to cancel or reduce the 8 and the 28. Now, depending on the level of your timetable, you may obviously see that the best number to use here is 4. But if you can't use 4, use 2. But I have trust in you guys. So I feel like I'm going to say a 4. So 4 into 8 goes 2 times. Why can't I write 2 properly on the screen? That's 2 times. And 4 into 28 goes 7 times. At this stage, nothing else is there to cancel. Remember, guys, this is a 2 here. I want to get, oops, it's a big wipe. So that's 27 over 8. Cancel this, we get 2 times. Very good. All right. So at this stage now, we end up with 7 multiplied by 27. I will end up with 189. And that's going to be divided by 5 multiplied by 2, which is 10. Again, we don't want to leave our answer here. And like I said, if you're leaving your answer there, I won't crucify you. I doubt if you lose in a half mark on an exam, it's going to hurt you. But half make up. So don't give away a half when you can prevent it. Okay? So take whatever you can get. Because you don't know what you might meet up on later on down in the exam paper where you wish you had just collected that half mark. So at this stage here, 189 divided by 10, I'm just going to go on my calculator. 189 divided by 10. That's going to tell me that it's 18.9. Now I'm only interested in the 18. And I need to know what the remainder is. So the remainder is going to be when I take 10 and multiply by 18, I'm going to get 180. And I need to get to 189. So that's 9 is my remainder all over 10. So the answer is 18 and 9/10. Okay? Is it clear?
Yes, sir.
Yes, sir.
All right. I feel like, even as easy as it is, I feel like I still want you guys to try one. Okay? So, I think I'm ready for you now. May I erase?
Yes.
May,
Yes, sir.
may I erase, guys?
Yes, sir.
Yes, go ahead.
I'll go ahead and snap off this one. 2 and 2/5 multiplied by 1 and 3/8 multiplied by 3 and 1/4. Go ahead, guys, and see if we can find anything to cancel out. All right? Don't be surprised if you end up with some very big numbers. Don't get scared. Okay? Just deal with it accordingly. I'll give you about 2 or 3 minutes. All right, so I think you guys might have gotten close to the answer by now. Let's see here. 5 multiplied by 2 is 10. 10 plus 2 is 12 over 5. Multiplied then by 8 multiplied by 1 is 8 plus 3 is 11 over 8. Already missing something we can cancel out. So that's good news. And 4 multiplied by 3 is 12. 12 plus 1 is 13 over 4. So there's not a lot to work with here, but there is something to work with. All right, that's good. So far, observation, only the 8 and the 12 seems to have something in common. The 8 and the 13 doesn't have anything in common. The 5 and the 11 doesn't have anything in common. Oh, funny enough, if you want, you can use something to cancel the 8 and the 12, or you could just go right ahead and use the 4 and knock out the 12. As you would have seen from the previous example, the choice you make will not affect your end result. So at first glance, the first thing we see is the 8 and the 12. So that's that me work with. So 4 into 8 goes, 4 into 8 here goes 2 times, and 4 into 12 goes 3 times. All right, so that's the first thing I see. That's it. All right, based on the problem, that's it. So we're just going to proceed then to say 3 multiplied by 11, or pardon me, 3 multiplied, because I can do this in my head. 3 multiplied by 39, but by 3 is 39, and 39 times 11.
429.
Correct. And at the bottom here, we end up with 5 multiplied by 2 is 10, and 10 times 4 is 40. All right, leaving the answer there may cost you a half a mark, so we're not going to give away anything. Okay, everything counts. So go on our calculator to be typing 429 divided by 40. It gives us an approximated answer of 10.725. We're only interested in the 10. Now, using that 10 now to calculate the remainder, 10 times 40 is 400. And we're trying to get to 429. So that leaves us with a remainder of 29 all over 40.
10 and
all right?
29 over 40.
Good. So I'm assuming that everybody in here perhaps just knocked that right out of the park. All right, let's move to division, guys. Okay. Now we can't divide more than 2 things at the same time. Okay. So unlike multiplication, where you can multiply more than 2 things at the same time, with division, you can only do it with 2 terms, two quantities. So the instruction is, guys, write for me. When dividing 2 fractions, we must change the sign to multiplication. We must change the sign to multiplication and invert the last fraction. That is the fraction that comes after the division sign. And we invert the last fraction. Now, some students are accustomed to saying flip the last fraction, or some will say reciprocate the last fraction. And then other students will just simply keep it simple by saying turn the last fraction upside down. So invert, reciprocate, flip, turn upside down, all those terms means the same. All right? And you'll realize soon enough that division and multiplication is more or less one in the same, with the exception that division requires you to invert the last fraction. And then it automatically becomes a multiplication problem. So starting off simple again, let's say we end up with something like, let's keep it simple, Mr. Peart. Let's do 4 over, say, let's say 4 over 15, right? Divided by, that's a division sign, okay? Division sign, that's a division sign, guys. So 4 over 15 divided by, say, something like 2 over 3. Okay? So for whatever reason you're working a problem, you end up at this position here. So you're just going to rewrite the 4 over 15, and you're going to change that division sign that is in the middle here. Looks like a minus, guys, but see me, I put the dot upon that bit. Dot. That's a division sign. So 4 over 15, change that division sign to a multiplication sign, and we're going to invert the last fraction, which is going to then be 3 over 2. All right? And at this stage now, we simply do what we just, passed. We just learned how to multiply fractions by canceling. So it's evident that 2 will knock itself out and go one time, and 2 will go into 4 twice. And you'll also recognize here that 3 goes into itself once, and 3 into 15 goes 5. So we end up then with 2 multiplied by 1 is in fact 2, and 5 multiplied by 1 is in fact 5. And since our answer has come out to be a proper fraction, then we leave it as it is there, as 2/5. Is it clear?
Yes. Clear.
Yes, sir.
Yes, sir.
Yeah.
So if I were to give you one like this, then I trust that you'll be able to do it. So let's just jump right to the mixed fraction, because we have some other questions that I would like to touch. Okay. So let's say we end up with, no, just pick one random question. Let's do something like 4 and 2 over 9 divided then by 1 and 3 over, what can I choose here now? Let's choose 1 and 3 over, doesn't matter. 1 and 3 over 8. Yeah. Maybe we don't get anything to cancel out. Because like I said, I'm not using a textbook. I'm just coming up with random numbers. I could just squeeze my textbook here. In fact, I'm going to grab my textbook in a second. Let's hop onto this one. So we have 9 multiplied by 4 is 36. 36 plus 2 is 38. And that's going to be all over 9. We don't ready for the flip yet. Let's take our time. Let's write down back our division sign. We're not ready for the flip yet. Some students, they're quite advanced, so they tend to take 2 steps simultaneously. Nothing wrong with that, right? But I like to take my, one at a time. That's just how I like doing it. I like teaching it that way, and I like doing it that way. 8 multiplied by 1 is 8, plus 3 is going to give us 11 over 8. All right? And now we're going to have to write 38 over 9, and we're going to then change the division sign to a multiplication and invert the 11 over 8, which then becomes 8 over 11. My screen is freezing, guys. Hold on. I don't know why they're asking me to purchase this app. Well, that is 11. I don't know why my screen is freezing, but okay. It decided it wants to malfunction right before we get to the important part of the class. So that's 8/11. All right, so now we end up with, all right, so this is a perfect example where we end up with nothing that can be cancelled out. So now we just simply end up with 38 times 8, large number, big number that. 304, not a very big number anyways. And that's going to be 9 times 11 is 99. So hop onto our calculators. Once again, I'm not thinking about my 99 times table in no way, shape, or form. So I need to have my tool. As a math student, you need to have your resources right at hand. When certain numbers go out of the scope of your timetable, then you have to know how to manipulate the tool, which is the calculator. So once again, you go on your calculator, you type in 304 divided by 99, it should give you an approximate answer of 3.07. 0 and one bunch of other numbers. Yes, go ahead.
Sir, in the first one you flipped the 4 and the 15, but in the second one you didn't flip the 38 and the 9.
I didn't flip the 4 and the 15. I flipped the 2 and the 3. Look carefully. Notice that the 4/15 came back down as 4/15. And the 2/3 was turned upside down to be 3/2. You spot it?
Yes, sir, I saw it.
All right, so it is always the last fraction that we invert, never the first one. So 304 divided by 99 gives us an approximate answer of 3.070. The only thing we're interested in is the 3. The 070 is not our remainder, as I've heard 1, maybe 2 students throughout the course of this week might have said. So the 3 then multiplies the 99 and give us 297. So we need to calculate how much more we need to get to 304. And so minus 304 from that, we realize that we get a 7 as our remainder over 99. All right? And that there gives us our final result. Okay? So in this case, then we end up with nothing to cancel out. And occasionally that's going to come up. All right? Good, good. And so it's 8 o'clock. That is good timing. We have half an hour now to actually go through some structured exam questions, right? Exam questions that you will most likely see on an assessment paper or a practice paper or even at the level that you're at, a CXC paper. Oh, gosh. All right. Now, let me start off with, since I have access, I'm now looking at a past paper. And I'm looking at the past paper that I failed. Yes, guys, I failed math at one point in my life. I wasn't always very good at math, okay? But in 2008, I'm looking at that paper. And in 2008, question 1A, part 2, the instruction was, write down this instruction, guys. Express as a single fraction. 3 marks to it. Guys, I'm looking at the paper now. Express as a single fraction. I don't know why I feel like I pose this to me. I really don't know why I feel like proving this thing to me. So let me show you. Hold on, guys. But sometimes I tell people, say you're using a past paper and them think I trick them. So Is there a way to switch camera? Okay, there we have it, guys. You see it? Look at the bottom there, so. So right down here, so you see? 2008. And this, I can see the color of the paper is brown. So you know, it's a long time to have that paper here, right? And there is a question right there. Express as a single fraction. I can write it down since the guys are you guys seeing it?
Yes, sir.
Okay, so you see, section 1, answer all questions in this section. All working must be clearly shown. Question 1A, part 2.
I'm not seeing it properly. I need our glasses.
See there? 2 and 1 over 2 minus 4 over 5, all divided by 3 over 4. I can go back to share my screen now. So there's the evidence that I'm using an actual past paper. So I'm now make up stuff in my head. Let's go. So it is 2 and 1 over 2. I tell you, this is the way how I teach math. The questions in the CXC give most of my students them. I find it very difficult to understand how them get it incorrect in the past. Because I always just give them some question, it just hurts in the head. I just feel like I have a vengeance against my students. Then whenever I'm teaching them, I don't know why I always choose to give them pitney or so hard question. I just feel that if you're able to manage the tougher questions that are not very common, and you do end up getting a question that is weak, like this one here, so we don't have much working out to do. Ask me how me get this question wrong in 2008. I cannot tell you. I don't know how, but I got it wrong. Or maybe I got it right. I don't even remember. I don't remember seeing these questions, in fact. Anyways, that is the question, guys. So only one. All right. So when you get questions like these, ladies and gentlemen, you have to try to work these questions out in parts, guys. And parts, we try to work them questions out in. Okay? Parts. So when we say parts, it means that you need to work out the top part of the problem. I'm going to label the question. I'm going to label the top section of the problem A. And I'm going to label the bottom section B. And then I'm going to just go down here. So I'm going to write A. And then I'm going to work out A. So the A section of the problem requires me to do only one conversion, which is to say 2 multiplied by 2 is 4. 4 plus 1 is 5 over 2. Take away then. 4 over 5 is just 4 over 5. There's nothing to convert. Now we have been through the rigorous training of how to subtract fractions, because this is the very first thing we did when we started the fraction calculation. So we're going to go ahead and find the LCM, which is 10. 2 into 10 goes 5 times. That's 5 here. And 5 into 10 goes 2 times. Put that 2 here. Guys, remember to keep your mics on mute just in case there are background noises where you are. Because remember the class is being recorded, okay? All right, so 5 multiplied by 5 is 25. Whoops, where am I putting the 25 here, Mr. Peart? Should be online. So 25. And then we have 2 times 4 is 8. So then we end up with an answer, or we end up with a result for the top part of the problem being equal to 17 over 10. Now, there is no point in us turning that 17 over 10 to a mixed fraction, because the 17 over 10 is not our final answer. Remember, so we have one B section down here, so. But the B section, there is nothing to do. There's no conversion to do. There's nothing to add or nothing to subtract or nothing to multiply. It's just a number at the bottom of the fraction. So then we can just proceed to just take that 17 over 10, which was the answer that we had for the top. And that line, the line that we see right there, so underneath the 2.5 and the 4 over 5 is called a fraction bar. And that fraction bar means division. So they're asking us then to take the 17 over 10, which is the solution for the top part of the fraction problem, and divide it by 3 over 4. And we just came off division. But we know, so we just take the 17 over 10, and we just change the division sign to multiplication, and flip the 3 over 4 to be 4 over 3. And like we've seen in the examples at the beginning of this class, at the beginning of multiplication, in this case here, we only have one diagonal that can be reduced, which is the 4 and the 10. Now, 4 can't go in a 10, but there's a number that can go into 4 and into 10, which is 2. So 2 into 4 goes 2 times, 2 into 10 goes 5 times. And I believe that we've reached our limit of cancellation. So this is 17 times 2, which is 34. And then we end up with 5 times 3, which is 15. This question is worth 3 marks, as you would have seen earlier. If I gave you this question on my assessment sometime next week or throughout the year, and you leave it right here, so I'm going to be brutal with you and take off 1 mark and only give you 2. But sir, nothing. You know better, so do better. You know you are to write your answer in its lowest term. The instruction was expressed as a single fraction. So 34 over 15 would mean that my answer is going to be 2, because 15 goes into 34 twice. And there should be a very small amount of remainder of
4 over 15.
over 15. And that is how you scrape up 3 marks from CXC. Sir, it not gonna look so easy when it come next year. Of course, you just don't see it for yourself a while ago. This is way in 2008, This was like what? 8 from 24. 16 years ago, And maths did hard in time then. So what you mean saying I'm go easy? All right? Is it clear? Let me give you one of similar nature to try. May I erase?
Yes, sir.
Yes, we can.
So I'm going to give you one of similar nature to attempt. All right? Similar nature, I never say the same thing, So I'm going to make you do more work. So you have 3 and 3 over 5, all divided by 1 and 2/5 minus, sorry, not 1 and 2/5, 2 and 2/5 minus 1 and a third. Go ahead and solve that question. I'm giving you a few minutes. I'm not giving you more than, it is 8:11. I'm giving you until 8:16. So speed up.
Hold on, that looks slow.
Pardon me? I didn't get that. Oh, I guess it's my slightly unmuted. Okay. I feel like you guys are close to the answer, so I'm going to try to catch you up because I have another question that I would like to see how would we go about it. So I'm going to try to catch you guys at the end. Let's see. Once again, very similar to example number 1 we just did. We're going to label this section of the problem A, B, and C. Sorry, well, A and B in this case. A and B. Now, the A part of the problem, we have one little bit of work to do. Not much, but just a little bit, where we just have to convert. So for the A section, not much work to be done. So let's just do what we need to do here. Convert 5 times 3 is 15. 15 plus 3 is 18 over 5. Let's put a little box around this because we're coming back to this in a second. We're not finished with him yet. I'll be right back. We're going to go down to the B section now. And we have 5 multiplied by 2 is 10. And 10 plus 2 is 12 over 5. I'm going to take away 3 multiplied by 1 is 3 plus 1 is 4 over 3. Now, in the B section, we need to take an extra step. We need to do some working out here. Simplify these 2 fractions here. So the LCM here is 15. 5 into 15 goes 3 times. We're going to put that 3 at the top here. And 3 into 15 goes 5 times. Put that 5 right above the 4 here as a time sign. 5. Oops. You guys know there are 5 that, you know. Okay, ready. So 3 times 12 is 36. And 4 times 5 is 20. So we end up here with 16 over 15. That is the answer for the bottom section of the problem. So now, the answer that we got for the top, which is going to be, which would have been 18 over 5. Now we're ready for the answer there. So this is our fraction bar right here. So that's going to be divided by 16 over 5, 16 over 15. This is such a good question. Wow. And I'll just make it up in my head, you know? I swear. I'm not looking at any past paper. This is working out to be a really nice question. All right, so this is 18 over 5 multiplied by, I'm going to flip the 16 over 5 to become 15 over 16. Oh, this works out to be a really nice question. So now 5 into itself 1 time and 5 into 15 3 times. And then we look at the fact that, 18 and 16, well, 16 can't go into 18, but it looks like we can use 2 to reduce the 18 and the 16. So 2 into 16, 8, and 2 into 18, 9. I feel like there's a question you guys want to ask me. So since you don't want to ask me, I'm going to ask myself. Sir, what if I did not see that 16 and 18 could be cancelled by 2? What if I only cancelled one diagonal and then I, for some reason, forgot to cancel the other? Will my answer be incorrect? No, but you're going to end up with a very large number which can still be reduced further. So that I feel like if you can just reduce it from early, it's easier to simplify 16 and 18 than to reduce a number like 308 over 54. It's harder to see.
Just a second. What I did,
yes.
What I think I got wrong was when you took the 36 from the 20 and got the 16 over 15,
Mm-hmm.
I thought that it should be reduced.
Oh, as in 16 over 15 reduced, like cut down further?
1 and 1 over 15.
All right. So I was saying that the only way we need to do that is if that is your final answer.
Oh,
Because if you
okay.
convert this to 1 and 1/15, when you're ready for it again, you have to go reconvert the 1 and 1/15 back to 16/15.
Yeah, I get you. I get you.
So yeah, the only time we are gonna do that is like when you finish. That is my answer. That's what you're gonna use to give me my 3 marks.
Okay. Okay.
So that's 27/8 here. So 1 times 8 is 8. And so at this stage now, all right, so you see now, I will final answer this now. So now, when I have no more steps to take, we can therefore go ahead and say 8 into 27 was 3 times. And since 3 8s is 24, I need 3 more to get to 27. And that's going to be over 8. And that now is our final result. Okay, so nothing wrong if you convert the 16/15 to 1 and 1/15, But that's kind of like doing something that we never ask you to do.
Right. Right.
And there were some questions that I had sent in the group Sunday night. So when you saw the questions, you guys weren't at fractions as yet. So I'm assuming that you guys may not have been able to attempt them. I don't even sure if I had sent them in the online class, in the online class group. But if you
Yes.
saw them, or it was sent, okay. So now you're able to actually do or try some of those questions. But there is a particular question on it that is mixed with PEMDAS. And before we end tonight's class, we have to look at an example where PEMDAS plays an important role in the first step, or it plays an important role in your decision making.
Could those work be resent? Because this is my first time.
No problem.
First class.
Yeah, erase.
Yes, go ahead.
I check in on my usual people. Kay, and I haven't heard your voice since night. Shireen, am I good?
Yes, sir, I'm okay.
Okay. Kayan,
Yes, I'm alright.
I normally hear those persons' voice. So I wonder if they're dead or alive. All right. Boom. Three and 2/3 minus 1 and 4/7 or 4/5 multiplied by 2 and 5/8. So 1 and 4/5 multiplied by 2 and 5/8. All right. So in this situation here, you're being tested. And what you're being tested on is, do you remember the order of operations? Don't believe that the order of operations ends at whole numbers. Or just also we applied it when we had a decimal problem, it don't end there, it follows you everywhere you go, including fractions. So in this case here, if there's a student who does this as their first step, not care how beautiful the rest of the working out be, it wrong. You cannot subtract at no given point before you multiply. That's breaking the ultimate fundamental rule in math. So if you do your conversion nice and you find your LCM and everything nice and you get one nice number and you go out yourself, you're wrong. Sir, not even half mark. Not even half mark, me not give. Not even half mark. Because the rules of PEMDAS, and I know my student who spoke earlier said this is her first time. So I'm still not lenient for you either. Okay. So I'll resend all the links to the classes that were done before. We just started recording classes Tuesday gone, but I had sent a link in the group as it relates to what you hear me talking about called PEMDAS. So I'll resend it, or I'll have one of my students resend it. Somebody can resend it from now, the PEMDAS YouTube link, so that the new student can watch it. And I'm the teacher on the YouTube as well. So you can watch it and catch up and see what we were talking about with PEMDAS. All right, boom. Here we go. Multiply first. But before we even go to the multiplication, let's do our conversion. 3 times 3 is 9. And 9 plus 2 is 11 over 3. Take away 5 times 1 is 5. Plus 4 is 9 over 5. Multiply then by 8 2s is 16. And 16 plus 5 is 21 over 8. All right, so we don't end up with anything to cancel because 8 cannot go into 9 and 5 cannot go into 21 and 5 cannot go into 9 and 8 cannot go into 21, and there's nothing to reduce any one of the numerators with the denoms. So we're just going to go ahead and just multiply across. We're going to end up with a very large number than what we would usually end up with on an assessment. But as you know, guys, I'm just picking random questions. So 9 times 21, that's going to give us 189. You don't really end up with numbers like these unless you make up your own questions. And then we end up with 5 times 8, which is 40. Okay? But no problem, nothing wrong with that. That's so fine. Maths are maths, you know. So we have LCM here, which is going to be 120. And there are 40 groups of 3 that can come from 120. Because 3 into 120 goes 40 times. So times that by 40. And then we end up with 40 into 120 goes 3 times. Okay. Now 11 times 40 is 440. And 3 multiplied by 189 that's 567. Now, usually we don't end up with our answer being a negative answer. Rarely does that happen. Rarely, right? But in this case, right, math is maths. So once you work it out correctly, you're going to be fine. All right. Now, this brings us back to our fundamental concepts of O and half. So if you want to use the O and half, as I said, you don't need to. I think I only use O and half when I'm introducing the concept of negative and positive numbers. But this, you have your tool right beside you. You have your tool in. So use it. 440 minus 567. And you get negative 127 all over 120. And these numbers that you're seeing on screen are as a result of the fact that I just made up some random numbers just to bring the concept across. So finally, then 120 can go into 127 just one single time, leaving a remainder of 7. Don't forget the negative answer. Negative. So that's negative 1 and 7 over 120. Okay? So that is how the cookie crumbles when it comes to fractions, right? When it comes to like a structured exam question. But fractions is wide and far because you can get worded problems involving fractions, but it will not go outside of the scope of you having to add, multiply, subtract, or divide, or do some combination questions. What it boils down to is your English language and your ability to read and interpret a question and decipher whether you need to add, subtract, multiply, and divide. And that just pretty much comes down to you being resourceful and going outside and finding questions and testing yourself. Because as you know, guys, our class time is limited. to just working examples, giving you the concept, and then hopefully that you guys can use up the resources that are outside. All right. But that brings us to the end of the topic of fractions, right? There are some questions that were sent in the class group, so you can attempt those. My WhatsApp device is always open for verification. I'll always give you a prompt response. And if there aren't any more questions, I believe that we have approached the end of our session. Any questions from anybody?
No, sir.
All right, dope. In our next topic,